Myself Ishwar Ganesh Muttikuru and I am currently studying in class S5. Today I am here to present a topic from our Excel subject which is k-means clustering. Let us know about k-means clustering methods. First of all, k-means clustering is a popular machine learning algorithm used for unsupervised learning, and k-means clustering is one of the most widely used unsupervised learning algorithms in data science and machine learning. It is used to classify a dataset into a specified number of clusters based on the similarity of the data points. And the main goal of this k-means is to partition out the dataset into k-distinct groups where the data points within each group are more similar to each other than to those other groups. So this clustering technique is particularly useful in explanatory data analysis, customer segmentation, and pattern recognition. Let us know about in this task. We will implement this k-means clustering algorithm to group a dataset into three clusters. The output will be a variable GRB containing the cluster assignments for each data point. And in the next problem statement, let us know about the problem statement. Give a dataset X of numerical data, and the goal is to apply the k-means algorithm to group the data into three clusters. When three clusters means k equal to 3, then the result will be stored in a variable called grp. We'll call as grp, and which will hold the cluster assignment for each data point. And the algorithm will be applied using MATLAB's k-means function, and we will visualize the clusters to access the results. And this problem demonstrates how unsupervised learning can be used to discover inherent groupings in data. And concept explanation is k-means clustering works through the following iterative steps. We have four steps. One is initialization, and second one is assignment steps and update step, and the conclude is repeater. Let us know about initialization. It's randomly select k initial centroids, one for each cluster. And the second one is assignment step and assign each data point to the nearest centroid. This step uses the Euclidean distance between data points and centroids. And third one is update step. Let us recalculate the centroids by taking the mean of all data points assigned to each centroid. And the fourth one is the assignment and update steps are repeated until the centroids stabilize, meanings there is no significant change between iterations. This one is repeater. And this k-means algorithm aims to minimize the sum of square distance between data points and their respective centroids, which results in compact and well separated clusters. And we know that choosing the right value of for k is critical, and methods like the elbow method can help in determining an optional number of clusters. And data set and data pre-processing, we know that for this task, assume that the data set consists of x and of n data points and m features. It is common practice to check for missing data and normalize or standardize. So for check for missing data is handle any missing of nan values in the data set. And second one is normalize or standardize to ensure that features with different scales do not dominate the clustering process by scaling them to have a mean of 0 and a standard deviation of 1. And the third one is visualize. Before applying this clustering, it is helpful to visualize the data if to check if there are any obvious patterns or separations. And the next one is model building and implementation. We know that we are implementing this model in MATLAB. So in MATLAB, this k-means function is a built-in tool to implement the k-means algorithm. Uh, we have the given the data set X and the number of clusters k equals to 4. The function will return the cluster assignments GRP and the centroids of each cluster Here, how the model is built. So now we all know we want to know that how the model is built. There are three methods to build the model. One is load data set and apply k-means, and third one we can get output by applying this before two methods. Load data set means by importing the data into MATLAB. And second one is we want to implement this k means x is equals to 4 to partition the data into three clusters. And later we can get the function retains the group assignments for each data point and the final centroids. X equals to take this random red comma 2 and it's 2 red comma 2 again and minus 2. Next one RA red comma 2 plus 5. Here x is equals to random 100 comma 2 plus 2 and the random 100 comma 2 minus 2 and the random 100 comma 2 plus 5. Here we create a simple data set with x with 300 points, and it combines with the three different groups of random points. One is as I said before 100 comma 2 centered around 2 comma 2 and 100 points centered around minus 2 minus 2 and 100 points centered around 5 comma 5. And random 100 comma 2 generates random numbers following a normal distribution. And coming next step, when the k means clustering we k equals to 4, we take in the given data set. Here we define the number of clusters as a 4, and this means we want the k means algorithm to divide the data into 4 groups. And k wants to be in small. And coming to the next point, we want to apply the k-means clustering in MATLAB is grp, comma, centroids equals to k-means, open bracket, capital X, comma, small k. And this one is for applying k-means clustering. K-means we take the given data is x, capital X, comma, k, applies the k-means algorithm on our data set X. It returns the GRP, the cluster index assigned to each point, which cluster it belongs to. And the centroids is the coordinate of the center points of each cluster. And next step, visualizing the clusters in MATLAB. Let us figure G scatter, open bracket, capital X, and open bracket, comma 1, comma, again capital X, open bracket, comma 2, comma, and the GRP, comma, this one is RBG, all must be in small letters, comma, and OSD, and close bracket, and hold on. Next one. Next plot. Centroid. Given centroids is comma 1. Next centroids is comma 2, comma kx, and the marker size. And we take a 12 as line width, comma 2. And next one is title. On their title, applying k-means clustering. The k-mean clustering we take k equals to 4, and we want to take two labels. One is x label and y label. First of all, we take one x label. X label as a feature 1, and y label as feature 2. Take it as a legend as a cluster 1 and cluster 2. We taken two clusters. One is cluster 1, second one is cluster 2. Cluster 2 and comma cluster 3, comma, and we take centroids and location, comma, and best. And hold off. This one is a sector plot is drawn showing the points colored by their assigned clusters and the difference colors RBG. RBG R we take three letters RBG and markers as OSD, RBG and OSD and are used for different clusters. And these androids with a block of X marker and titles, labels, and legends are added to make the plot easy to understand. In simple words, we created a random data clustered into four k equals to 4. We created random data group into four clustering using k-means and plotted it beautifully, showing each cluster with its center. And let's run this program. Here the output. Uh, Let know this output. The random points. See this random points k equals to 4 now. 1, 2, 3, 4. These random points you generated are successfully separated into clusters. Even though the data was random, k-means could find meaningful and groupings. This one group, this one group, this one group. K equals to 3 as a k-means clustering. Even if the data was random, k-means could meaningful groupings. You can clearly see how cross points are grouped together and how the centroids represents the average center of each group. Cluster 1, red one which is cluster 1 and a square cluster 2, rhombus cluster, diamond cluster 3 and a circle centroids. This one a feature 1, feature 2. X path is feature 1 and Y path is feature 2. As we all know that k means clustering is equals to k equals to 4. Let us conclude this output. Simple way to say it, the output shows our random data points separated into four four clusters with a different colors, blue, red, and green, and orange. Shapes the black and the black X marks this X, four black X marks, and center of each group. Each group has four black X marks in the center. That's utilization. Let us know about dataset. A synthetic dataset X is created with three distinct clusters using random, and this dataset will simulate real world data where points are generated from different Gaussian distributions. So three different data sets are generated from different Gaussian distributions during taking data set X in random. And second one is k-means clustering. We know that we take the data set as k-means clustering, and this k-means function is applied to group the data. K-means clustering means grouping the data in into three clusters, and this ERP variable contains the cluster assignment for each data point. And coming to the third one as visualization, we know that we completed dataset and a k-means clustering. And coming to the visualization, in this code we went to the scatter plot. We added scatter plot, and a scatter plot is used to visualize the data points. The scatter plot helps to visualize the data points with each cluster represented in different colors. We know that the colors are represented in three colors, and that one orange, blue, red, green. The centroids of the clusters are marked with black crosses. These black crosses are four black crosses in each three color datasets. So this is the visualization in output. We can see in output these different colors and four black crosses marked in three group datasets. And this code effectively demonstrates the k-means clustering algorithm, which means providing a clear and visual understanding of how data points are grouped into clusters based on their similarity. So let us evaluate the results. After applying the k-means algorithm, the clustering results can be evaluated by three types: visualizing the clusters and cluster quality and interpretation. Coming to the visualizing the clusters, we need to plot the data points with different colors for each cluster and overlay the centroids. And coming to the next, cluster quality, evaluate the compactness of the clusters by looking at the within cluster by using sum of squares are called inertia. Using sum of squares called inertia. And coming to the interpretation, we need to analyze the characteristics of each cluster by examining the centroids. These three steps the success of the clustering process depends on how well the data points are grouped and how distinct the clusters are. And visualize, inspection, and cluster interpretation play an important role in understanding the results. And coming to the end, the conclusion, we know that k-means clustering is an effective tool for partitioning the data into distinct groups based on similarity. Based on its similarity, k-means clustering is an effective tool for parsing data into distinct groups. In this task, the algorithm was applied to group data into three clusters, with the results visualized to assess the effectiveness of the clustering process, which means K-means works well when customers are roughly spherical and are a smaller size. Tough, its performance can degrade if clusters are uneven or if K is not chosen properly. Nevertheless, K-means remains one of the simplest and most popular clustering algorithms in practice. And this is all about this presentation and concluding this. I thank you.